All right, guys, so 2.8 part 2. We're going to start off by solving this inequality here. Actually, four different inequalities, I suppose. But this is actually really simple. So they want to know what values of x, okay, make the function greater than 0. Okay? Well, think about this. If I was to do a sign chart, pick an x greater than 0, okay, and you plug it in. So that's going to be positive, and that's going to be positive. In other words, these two factors are never going to be negative if you think about it. Because when you plug in a negative number for x, you square it, it's positive. So then you're adding numbers to the end of that. So basically, for part A, all real numbers work. Okay? So you can plug any x you want in, and that function is going to be greater than 0. Now, same thing goes for greater than or equal to 0. Okay? Now, the thing is I'm not 100% sure, but I don't think that this will ever be 0. But it's the same thing. Okay? Now, here's the idea. You have a situation where x can be anything it wants to be, and the function's going to be greater than 0. Well, that kind of leaves out when the function's less than 0. Okay? So there are no x values that make f of x less than 0. So there is no solution. Okay? And then same thing for part D. So this is a special case. Okay? Special case. All right. Now, same thing up here. All right. Here's our equation, and we got to solve each of those inequalities. So, what do we have to do? Well, let's see. For f of x greater than 0, all right, pick an x greater than 0. So, let's plug in 1. So, if I let 1x be 1, so 1 squared minus 3, 2, that's positive. And that's positive 2, I believe. Yes. So that's positive. Okay? So, here's the idea, though. In this problem, there were no zeros. Okay? So if you set each factor equal to 0, you would not be able to tell me any real zeros. Here there are. So actually, before we do the sign chart, let's do this. Okay? So x is negative 5 halves. That's a 0. Okay? I can't factor that, so I'm going to leave it alone. All right. So for f of x greater than 0, we need to find the x's that make that true. Well, from negative infinity, let's do it this way. Let's write it down here. So A, negative infinity to negative 5 halves, okay, union with negative 5 halves to infinity, okay? And the reason why we don't include negative 5 halves is because negative 5 halves is the lone 0 for the function. Okay, so we don't include that. Why? Also, look, it says greater than 0, not equal to 0. That's the other thing. Okay, and actually more important. So for part B, now it's greater than or equal to 0. So now negative 5 halves is able to join the group. So all real numbers. Okay. Now again, what that means is I can plug any number in for x, any negative number, any positive number, any 0 I can plug in, and the function's going to be greater than or equal to 0. Now again, the inequality for C, f of x less than 0. Well, if you look up here, there are no values of x that make the value of this whole function less than 0. So the answer for C is no solution. However, for part D, for f of x less than or equal to 0? Well, we do have a value of x that makes the function equal 0, negative 5/2. So the answer is just simply x equals negative 5/2. Okay? Because that's the only number that when you plug it into the function, it's going to be less than or equal to 0. It's not going to be less than, obviously, but the or equal to part includes negative 5/2. Okay? So there's a couple special cases. All right, polynomial function f of x is positive, negative, or 0 for all real numbers, x. But a rational function can be positive, negative, 0, or undefined. Okay? Remember, rational function, you have a function over another function. So if the denominator is 0, that's where the undefined part comes in. Okay? This basically just explains how to find the zeros, or excuse me, how to find out where the functions are undefined. So we understand that. Moving on. Okay, so let the real number value of, so here's our function. Hang on a second. I'm going to write it here so we have a little bit more room. 2x plus 1 over x plus 3, x plus 1, x minus 1, excuse me. Okay? Now, what do they want? Determine the real number values of x that cause r of x to be 0 and undefined. Let's do that first. So part A, all right, real zeros. Okay, so the real zeros happen, okay, they happen when the denominator, or excuse me, the numerator equals 0. Okay, so r of x equals 0 when x equals negative 1/2. Okay, so that's the only real 0 of this problem, x equals negative 1/2. Now, they want us to find out when it's undefined. So what do? I take the denominator and I set it equal to 0. Okay, then I take each factor, set it equal to 0. So at x equals negative 3 and x equals 1, r of x is undefined. Okay. Then make a sign chart to determine the real number values of x that cause r of x to be positive and negative. Okay, so what we found here, okay, there are 3 points of potential sign change. Here they are. Okay, so we're going to make a sign chart. We'll make the sign chart right here. So I've got negative 3, negative 1/2, and 1. Actually, let's spread those out a little bit. Try to make this video shorter for you guys, but there's stuff you have to know, so I can't be too short. Okay, so basically I took these 3 numbers, put them on a number line. Now, I'm going to pick a number less than negative 3. So pick negative 4, for example. So what happens? I get a negative on top, and on the bottom, I get a negative times a negative. Okay? I don't care what the numbers are, guys. I just care about the signs. So what I do then is now I've got negative divided by negative times negative. Well, that's positive on the bottom. So we have f of x, or r of x, excuse me. R of x is negative on, or underneath the x-axis, pardon me. Okay, pick a number between negative 3 and negative 1/2. Pick negative 1, for example. So negative 1, if I plug that in, I get a negative on top, and then I get over a positive times a negative. All right, well, in reality, that's negative over negative, so I get positive. So r of x is positive between those two x values. Pick a number between negative 1/2 and 1. Pick 0, for example. So if I pick 0, I get a positive on top over a positive times a negative. Well, again, that's positive divided by negative, essentially. So my function is negative between those two x values. And then Okay? And then, lastly, numbers greater than 1. So if you pick 2, so you'd get positive on top, positive, positive. So everything's positive, which means you have a positive here. Now remember, at -3, the function is undefined. At 1, the function is undefined. And at -1/2, the value of the function is 0. Okay? So, when we write our answer, sorry, I'm going to erase some of this. Sorry. iPads are limited, guys. There's only so much I can do. So, from -infinity to -3, the function is negative. So, r of x negative from -3, oh, excuse me. Boy, I keep doing that. I did that today. Put the smaller number first, dummy. There we go. So from -infinity to -3, the function's negative. And then it's also negative from -1/2 to 1. Whoops, wrong way. Union -1/2 to 1. Now, r of x is positive from where? Well, it's positive from -3 to -1/2. Okay, that time I did it right. Good grief. Anyway, and then it's also positive from 1 to infinity. Okay? So that's how you figure out your intervals of where the function is negative and where it's positive. Find your zeros, find your x's where the function's undefined, and then use those numbers to make your sign chart. Okay, so next, now they're going to give us an equation to solve. Okay, they're going to give us an equation to solve. Well, there's a couple different ways we could do this. Okay, the way that we're going to do this right now, the method I'm going to use is I'm going to keep the fractions. Okay, I'm going to keep the fractions. But what I'm going to do is I'm going to find a common denominator. Okay, so my denominators are x plus 3 and x plus 1. So whenever I want to find the common denominator, I just take the two factors and I put them together. There's my common denominator. Now, whatever you did to the bottom, you have to do to the top. So the first denominator got multiplied by x minus 1, so that's 5 times x minus 1. In the second fraction, we have x minus 1. Well, we had to multiply by x plus 3 to get the common denominator, so I have to do that on top. Okay? So I distribute. So 5x minus 5 plus 3x plus 9. I just put them together. I mean, if you have a fraction, guys, and you're adding two fractions together, you have the same denominators, you can just make it 1. So this becomes what? It becomes 8x plus 4 over x plus 3, x minus 1. But I can factor a 4 out of that, so really it's 2x plus 1 over x plus 3, x minus 1. And in this case, guys, we don't have to write the 4 down that we factored. We don't have to do that because, honestly, the 4, for what we're doing, the 4 doesn't matter. Okay? So, now, if you look, that's the same inequality we got from the previous problem, if you notice. So, basically what they want to know is, when is this function negative? Well, we already know the answer to that. It's -infinity, -3, union, -1/2. I'm running out of room. 1. Okay? So when we did that, the function that we came up with was the same one from the previous example. Okay, so I can just kind of cherry pick the answer from there. Next, okay, well, now we have a radical involved. Okay, now we have a radical involved. So, what are our zeros? Okay, our zeros are x equals 3 and -1, right? Okay, so now we have to look at this too. We make our sign chart. Okay, so here's -1, here's 3. Now, for x is less than -1, look at this radical. If x is less than -1, that square root doesn't exist, okay? Which means that the function is undefined over there, okay? There's no values, none. Pick a number between -1 and 3, pick 0. So what do I get? I get a negative times a positive, which is negative. Okay. Bigger than 3, I get a positive times a positive, which is positive. Okay. So now what they want is they want to know what values of x make the function greater than or equal to 0. Well, -1 makes the function 0, doesn't it? Okay. And we're going to union that. That's a u, by the way. That's a terrible u. We're going to union that with the set 3 to infinity. By the way, guys, notice I bracketed 3 there. I bracketed 3 because 3 is one of my zeros. 3 counts. Okay, 3 counts. That's included. So that's my answer. Okay, last one, we're going to talk about an absolute value this time. Okay, well, what are our zeros? Okay, well, we only have one zero, x equals 2. Okay, but what else? We have this absolute value in the denominator. Well, the denominator can't be 0, can it? So we have a 0 at x equals 2, but x can't equal -3. So those are like our key numbers, okay? So -3 and 2. All right, well, let's look at values less than -3. All right, so at -3, the function is undefined. At 2, the function is 0. All right, so less than -3. So if I put, let's say I put -4 in. So I get a negative over really a positive, right? Because whatever this is, it's going to be positive on the bottom no matter what, if you think about it. No matter what I plug in for x, the bottom's always going to be positive because of that absolute value. All right, so that would give me a negative. Let's see, on the top here, let's choose a number between -3 and 2. 0. 0 minus 2 is negative. Okay, so I have a negative over a positive, which is still negative. And finally, if I choose a number greater than 2, my top's going to be positive on the bottom, so I'm going to get positive. Now, the problem wants to know, what values of x make this function less than or equal to 0. Well, from -infinity to -3, now I put a parenthesis there because at -3 the function's undefined. Okay, union with -3 to 2. But I bracket 2 because 2 is a 0. Since 2 is a 0, I bracket it. Okay, and there's my answer. So, we're done. So that's it. I kept it under 20 minutes, barely. I apologize for the length, but there's some special cases, and the rational functions are pretty important. So make sure you get this done, and we'll finish this up tomorrow.